A car accelerates from rest with a constant acceleration until it reaches 30 meters per second. It then travels with constant velocity from that point on. Let's say it takes 5 seconds to do that, to get to 30 meters per second. Meanwhile, let's say that we've got 10 seconds after the car has left, a motorbike sets off and it accelerates with a constant acceleration of like 10 meters per second. 10 meters per second. Per second is the acceleration. And the question is, when does the motorbike overtake the car? A lot of students think that they are trying to find this point here, car overtaken by motorbike, because that's where the graphs are intersecting. But no, because this point here is a moment in time. It is a special-ish moment in time. It's the point in time where the motorbike and the car are both doing 30 meters per second. They're nowhere near each other. The fact that the car is going at 30 meters per second and the motorbike is doing 30 meters per second is not relevant at all. What's happening here is they're going at the same speed, not they are in the same place. So how do we do this question? Well, we need to know when they're in the same place. That's when the car is being overtaken, and that happens when they've got the same displacement. So let's think about the displacement of the motorbike. If we have this point here, let's say this is the point where the car is overtaken, some random point in the future, then that means that the motorbike displacement is exactly the same as the car displacement. And the displacement, as I'm sure you well know, is the area under the VT graph. So this area here equals this area here. That will be the time at which they're overtaken. Okay, area of a trapezium. Well, we need to measure all the way across here. That's the bottom. That's t seconds. What about the other line here parallel to it? That's t minus 5, that length. So we're going to add them up, t plus t minus 5. And we're going to multiply by half the distance between them. And the distance between them, this height here, that's 30. Okay, equals area of a triangle. We have half the base times the height. Here's the base, t minus 10. And here's the height. Oh, I don't know, I'm going to have to work that out. Half base height. Right, let's work out the height. How far? It's going at 10 meters per second per second. So each second, the speed, or the velocity I should say, the velocity increases by 10 meters per second. So it starts off at 0. Let's think about it this way. V equals u plus at. Right, the original velocity was 0. The final velocity is what I want. The acceleration is 10 and the amount of time is t minus 10. So the final velocity is going to be 10 t minus 10, and that's what goes in here. Half base times height. Right, let's see what this looks like when we tidy it up a little bit. Nice. Okay, let's keep going. 5 times 15. Had to use a calculator for that one, not going to lie. T squared minus 20t plus 100. Right, let's get it all on one side. 5t squared minus 130t plus 75 plus 175 equals 0. Now I can use the calculator to solve that equation, but if I do, I need to pretend I did the quadratic formula. So I'm going to write it out. Minus b plus or minus the square root b squared minus 4ac all over 2a. 24.5758 blah 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 seconds, or using the minus 1.42. Now we know that t is bigger than 10, so therefore we don't want this solution, we want this solution, and to two significant figures, or probably three significant figures is safer. T equals 24.6 seconds. That's how you actually find the time when they overtake, and don't fall for the classic mistake of thinking that anything vaguely interesting is happening at this crossing point here.